Hello Math 10, welcome to lesson 4. So hopefully you've got these notes. Now we're going to look at this first problem we've got here is we've got a product and we've got the product of 14 and 16. Now you may remember the distributive property that you've done in the past where you were told something about multiplication distributes over addition and subtraction. So to go through and perform this multiplication here, we're going to look at using an area model. Now, I've got some grid paper here. It's broken up into squares. And we can think of 14, well, we could write it as 10 plus 4, couldn't we? So I'm going to put 10 plus 4 down here. And then we've got 10 plus 6 for the 16. So I've got 10 plus 6 over here like that. Now, using tiles, okay, this is what I get here. Now look at this. So what I've got here is I've arranged it so that this big square in here, let me just go through and highlight it. This big square here is a 10 times 10 square. And of course, that's going to give you 100 units, isn't it? And then over here, we've got the plus 6. So we've got 1, 2, 3, 4, 5, 6 this way. And these little rectangles are 10 long. So we've got 10 times 6, or 6 times 10. So this part here has an area of 60. Now going down this way, we've got this width this way is 4 units. And each little rectangle is 10 long. So we've got 40 in there. And then lastly, this part that I'm going to circle here like that is going to be 4 times 6 is 24 units. So guess what? We should see from our area model here that this product of 10 plus 4 times 10 plus 6 is going to be the area of the square, which was 10 times 10, 10 times 6, which was the 60, and then the 4 times 10, which was the 40, and then lastly, all the units, which was 24. Now, what does that all add up to there? That adds up to 160, 200, 224, isn't it? Now, how does that work with the distributive property? Well, I've gone through here. We can think of it like this. We've got 10 times 10 plus 6, and then we've got 4 times 10 plus 6. Now, using the distributive property here, what do we actually get? We get 10 times 10 in there, which is 100. Then we've got 10 times 6, which is 60. And then we've got plus for this one here, we've got 4 times 10, which is 40. And we've got 4 times 6, which is 24. And there you have it there. We've got 100, 160, plus 40 is 200, 224. And you can check it on your calculator. Clearly 16 times 14 is equal to 224. Now, did we really need to use grid paper there? Not really. We could have just sort of thought of any old rectangle like this, split it up into 4 sections. There's our 10 plus 4 this time. There's our 10 plus 6 here. And if we simply go through, even though the scale is not correct, it doesn't really matter. We've first of all got 10 times 10, which is 100. Then we've got 10 times the 4, which gives us our 40. And then the 6 times 10, which is 60. And then lastly, we've got the 6 times 4, which is 24. And the total area, which is going to give us the product, is just going to be the sum of all those, which gives us, again, that's our 224. So, I wonder how we could extend this to the product of two binomials. So here we have x plus 5, and we have x plus 6. Now we can use the same idea with an area model. So you'll notice on the top that I've got an x there, and that bunch there is 6. So that's x plus 6, isn't it? And then down here, vertically, we've got another x, and we've got plus 5 this time like this. Now, I've gone through and completed this already, and that's what I get there. All right, when I go and fill it all in, I get that rectangle there. So look at what we've got. It's a couple of interesting things to notice. First of all, this way we get x times x, which is this square, which is x squared. And then every other rectangle after that, we've got x times 1. So along here, we've got 6 x's. And then vertically this way, we've got 5 units. And each rectangle is 6 long. So that gives us, we've got 5 of these x's. Now look at all those units. All of those units come to 5 times 6. And we've got 30 units there, don't we? So if we look at this product here, if we were to go through and, the word that we can use here is expand, well, we've got, first of all, we've got the x squared, don't we? And then we've got plus 6x's, and then we've got plus 5x's, and then we've got, and let's just bring this down here, then we've got the 30 units. Now, this is interesting because the 5x's and the 6x's are the same type of rectangle, aren't they? So in algebra, we say that they're the same type of term, or they're like terms. So we could tidy that up a little bit and write it as x squared, and then we've got 6 plus 5, which is 11x, and then we've got the plus 30. So what we've done here, we've taken our product, okay, of two binomials, the product of those two, and we've gone through and we've done a thing which is in algebra is called expanding. Now, some people call it multiplying out, okay, but we're going to call it expanding, and this is what it looks like when it's expanded. Now, the interesting thing about it is this product is exactly the same, or equivalent to, rather, this expansion here. Now, another thing to note here is that what we have here is the product of two binomials, isn't it? It's a product because it's multiplication. And the product of the two binomials gave us, now, what did we call this type of polynomial the other day? Because it's got the 3 terms, we called it a trinomial, didn't we? Okay, now, as before, the same thing that we did with our our product of two numbers up there, we don't really need to think of it using the tiles like that. We could also just use a rectangle like this. So we could think of the x plus 6 as being across there, and then we could think of the x, and we had the plus 5 down here. Now, if we go through and we multiply here, there we've got our x squared, don't we? And then we can think of, we got the x times the 6. So we've got 6x in there. We've got the 5 times the x there. And then the very last one, of course, is 5 times 6, which is 30. And so there you can see, when we go through and multiply the two binomials again, we've got the x squared. We've got a 5x and a 6x. And, of course, they add to give us the 11x. And then we've got 30. So again, all right, just thinking of it with another type of area model there, we've got x squared plus 11x plus 30. Now, we could also use the distributive property to help us think about this. So with the distributive property, we could think of it like this. We could go through and we could say, well, first of all, this is multiplication in here, isn't it? So even though the sign's not there, remember, okay, we call this thing implicit multiplication. So we can think, first of all, we're going to have that, whatever that value of x is, times the second binomial, isn't it? X times x plus 6 it should have been. Okay, and then we've got 5 times, so, and we've got a connecting operation in between there, which is plus. We've got 5 times the x plus 6. Now check it out here. We can keep on using the distributive property here. That becomes an x times x, which is the x squared. And then we've got the x times 6, which we'll write as 6x's, 6 times x. And then for the second pair, we've got 5 times x, and we've got 5 times 6, which is plus 30. Now look what happens in here. we've got 6x's plus the 5x's, same type of term, and so we can simplify that to 11x. We've got x squared plus 11x plus 30. So that's the process by which we go through and we can expand two binomials. Now, we also have a kind of a quicker technique, which is probably a little bit more convenient. And this little technique we're going to call FOIL. Now, let me explain how it works. So, the F stands for first. Now, look what I've got here. I've got the product of two binomials. So, that means first there. So, the first multiplication we're going to do is we're going to do n times n. Now, hopefully you all realize n times n, okay, really can be written just as n squared, can't we? Now, the O stands for outside. So our next product is going to be on the outside there. Look at this. We got the n and we got the 4, which are both on the outside. So that's going to be n times 4. So we can write that as 4n. Okay, what's the I stand for? Well, the I stands for inside, and so the two inside numbers, in this case the 7 and this variable n, we can write as 7 times n. So we've got 7 times n there, and then L stands for last, and that's going to be the last term in each binomial, and that's going to be 7 times 4, which is plus 28. Now, once again, those are the same type of term, okay, 4n and 7n. So we've got 4n's, we've got 7n's. We can add those together to give us 11n. And then we've got the n squared, and we've got plus, and on the end there we've got 28. Now once again, what have we done? We've gone through and we've written the product of these two binomials. And so the product, when it's expanded out, or we could use the word multiplied out, gives us this trinomial here. And the little algebraic method that we used here, which we're going to use in future, is we refer to that as FOIL. First, outside, inside, and last. All right, which is a handy little method that we can use. Now, let's go through and try it with this one here. Now, this is a little different this time because you notice that instead of everything being added inside the binomial, we've got a subtraction there. So we've got to be careful of that. Now, we can think of y minus 2 as really being the same thing as y plus negative 2. Okay, so effectively, with a subtraction of 2, that 2 is sort of a negative quantity. Now, let's use our FOIL method here. So we're going to begin the first two terms, y times y, and how can we shorten that? Y squared, isn't it? What's the next one we got? We got the O in our FOIL, which is the outside, and we've got a negative 2 times y. So we're going to write that, because of that subtraction, we'll write it as minus 2y. What's the next one we come to? We come to the inside, which is 7y. So we'll write that as plus 7y. That's a positive quantity. And then L for last, we've got 7. And really think of it as being 7 times negative 2. And of course, 7 times negative 2 is going to be negative 14. So we can write that the same thing as subtraction of 14. Now, once again, what do you notice? We notice on the inside here, all right, or in the middle, those two terms are the same type of term because they have a y together. Now, we've got negative 2 of them and we've got plus 7 of them, don't we? So if we add negative 2 and 7, I hope you can do that mentally. So, oops, we've got y squared, negative 2 plus 7, yep, that comes up to 5y, and then we've got minus 14. All right, so that basically covers all the material we're going to be looking at for Chapter 3 and Lesson 4.